good afternoon, good evening. Whatever time it is, I do hope that you're having a good time. I'm Andrew Kamazinski at Hokkaido University of Education, and this is the last of a series of flips about critical thinking for the second version. And in this flip, I want to talk a little bit more about inductive arguments. So I want to explain a few concepts that are useful for understanding inductive arguments, and also just to recap how these differ from deductive arguments. Now, just to summarize from last week, generalizations are strong or weak. Generalizations can have a false conclusion with all true premises. So that unlike our other types of arguments, where in deductive arguments this was not possible, in an inductive argument, of which generalizations are one kind, it is completely possible to end up with a false conclusion even though you had all true premises. This is just part of the price we pay. So, we learned a few different ways to make generalizations stronger or weaker. The most basic of these principles is that you can make a generalization stronger by using more examples. So again, more examples is better than less examples. Similarly, use representative samples. So here we have the idea of cross-section. So this means if you're looking at a set of data, this is the part that you use to clip out what you're not going to use. So we have data here. The cross-section is the part of the data that we decide to use. So if we're using this part, that's our cross-section. Again, sample size. So if we use just this part, we have a very small sample size, and this is going to make our argument quite poor. Finally, it's important that you consider background rates. Background rates will tell you whether what you're doing is meaningful or not. So if I say that everyone in Asaikawa is a white person, this would probably not make any sense, because if we thought about Hokkaido in general, that's not the case. So without some special reason, it's not going to make sense to conclude that everyone in Asaikawa is a white person. So next concept that we want to think about. You need to read generalizations carefully. So in Anthony Weston's book, he says statistics need a critical eye and think when you read statistics. So let's consider the following sentence. Most people like many kinds of fruit. This sentence is very ambiguous for a couple of reasons. For one thing, we have a most, and for another thing, we have a many. Neither of these is especially clear. But one thing that's nice about this is that the argument is probably going to wind up having a true conclusion. Let's think about it a little more carefully. Consider the following sentence. Most people like many kinds of fruit. Could we say that this means most people like apples? Could we say it means that most people like oranges? Could we say it means that most people like apples and oranges? We might be able to say all of these following from that claim. So we need to be careful. What sort of data did we have to back this claim up? So if I went to the Asaikawa station and I asked several hundred people, do you like apples? Then it seems like the best conclusion I can say is that people in Asaikawa like apples, or many people do. If I asked them about a variety of fruits and they said they like them all, then it makes sense for me to say the sort of conclusion that I drew the first time. Could we say most people like only apples? Maybe. Could we say someone likes only strawberries? Now, if we make our claim this narrow and we just refer to one somebody, then it's probably pretty easy to make this claim true. What about someone likes all fruit? In this case, we just need to find one person for whom it's all true. If we want to say this claim, most people like only apples, this is going to be a hard claim to prove, because I've said most people, so now I need to refer to many different people to get this conclusion, and I need to make it so most of them only like apples. This is a hard conclusion to reach, because now I need to get more than half of people to like only apples. Let's think about this. We want to consider this sentence. Most people in Asaikawa can speak Japanese. Now, if we want to say everyone in Asaikawa speaks Japanese, there's a problem. We don't have enough evidence for that. We've only shown that most people do. If we want to say most people at HUE Asaikawa speak Japanese, we have some support for saying that. If we want to say someone at HUE Asaikawa speaks Japanese, it seems quite likely we can prove that. If we add a someone at HUE Asaikawa probably speaks Japanese to our conclusion, it's going to be very easy to make this claim. Think about this sentence. So I'm sure that you can tell, but if we go down this way, The fourth one is the easiest to prove. The third one is a little bit harder, second one a little bit harder, first one quite hard. Now, the trick is that we're doing two things. One thing that we are doing is that we are narrowing the scope. So the smaller the claim we're making, the easier it would be to defend that claim. The other thing that we are doing is that we are qualifying who fits under the scope. So we're saying that if one person fits this, it counts. Consider the following sentence. Most people in Asayakawa can speak Japanese. This is probably true. Now, could we say this? Everyone in America speaks Japanese. One of the problems here is the location we're talking about has shifted. So based on most people in Asayakawa can speak Japanese, it's doubtful we could say everyone in America speaks Japanese. This one, no one at HE Asayakawa speaks English. It's doubtful we can say this either based on this sentence, because speaking Japanese and speaking English are not exclusive. It's possible to be able to speak both. Next, someone at HE Asayakawa probably speaks Japanese. Now, on the basis of this sentence, it's quite easy to support that statement. If most people in Asayakawa speak Japanese, then someone at the university probably will speak Japanese, because we're going from larger to smaller. So this is something that is important to do, is with the data that you have, go from a larger thing to a smaller thing. Now, the main thing that we are doing here is we're thinking about our language. So are we saying things that are too extreme? So using all, none, no, every, must, cannot in our conclusion. When we do that, it's probable that we're doing an ippankashi sugiru, an overgeneralization. We're saying more than we can. Second, are we saying something stronger or weaker than the data we have? So are we changing a word like many, most, or some? Are we doing something that makes it so that our argument is easier or harder to prove? Finally, are we changing the area that we're covering? So again, if I make a claim about Japan, it's one thing to then make a claim about Hokkaido. It's something else to use the same data to talk about America, because I have very little basis for being able to say something about America just based on data from Japan. Another thing we need to consider about generalizations is that generalizations are always subject to counterexamples. So there's always something that could happen that's going to make a generalization false. So again, generalizations are strong or weak, and they can always be wrong because they work by drawing a conclusion based on data. They do not have the property that we were talking about with deductive arguments. They are not truth-preserving. The bigger the claim is, the easier is it for it to be wrong. So for instance, this claim, no American can speak Japanese. All I have to do is find one American who speaks Japanese to show that this is false. No Japanese student is taller than Dr. K. All I have to do is find a Japanese student who's taller than me. I know at least 3 at this university alone. So again, no Japanese student is taller than me. Another claim, all white people speak English. All I have to do to disprove this claim is find a white person who does not speak English. So if I find a Frenchman who doesn't speak English, if I find someone from Poland who doesn't speak English, then I have proven this is false. Again, it's all claim. All Chinese people prefer rice over bread. I just have to find one Chinese person who prefers bread over rice, and I will have shown this claim to be false. I don't think that would be too difficult. Some parts of China are bread-based cultures. So again, easy to show that this is false because of this all claim. It's too big. A counterexample is an example that shows a generalization is false. So this is what the meaning of the word counterexample means. So this is something along the lines of hantide. For example, we have now found that there are black swans. So in the West, it was believed for a long time that all swans were white. This is still reflected in the Japanese word for swan. Now, a black swan proves this. Another one. In my policies for my classes, I do not accept absence slips from different things like badminton clubs or other such events. But This is not a hard and fast rule because I do exempt people for kyoku field kenkyu and other required things like the kaigo field kenkyu. All you have to do to disprove a generalization is find one counterexample. Consider this graph. Let's say that this is a graph of when it snows in Aseikawa. So it snows pretty frequently. So let's say I want to make a generalization. And the generalization that I decide to make is, I make the generalization, it snows every day in Aseikawa. What do I need to disprove this? The answer is I just need one day, make it here, make it here, make it here, where it doesn't snow in Aseikawa. So, if we say it snows in Aseikawa every day, this is too strong of a claim. If we can find one day where it does not snow, we have a counterexample. So there were several days in the summer where it was very warm. There's no way it's going to snow. We're talking 30 degrees centigrade. Now, right now, it does snow pretty much every day. So if I narrowed my claim, if I said it snows every day in January, this might be true. Is that if we want to make a claim about everything on this graph, we can begin with this. Every point is blue. In this case, we would have an immediate counterexample because there's one red point. But we can fix our conclusion. We can make it a legitimate generalization. And we do that this way. We make the claim, most points are blue. If we do this, we have made an improved argument because it is the case that most points are blue because we've corrected for the counterexample. When looking at an argument, think if there is an exception. Think if there is something that breaks the argument. If there is, make a change to fix the argument. Usually these problems will happen because we're using words like all, none, no, most, every, few. We are making claims that it's hard to back up unless you have complete grasp on the data. In short, we've looked at two types of inductive arguments. Both generalizations and arguments by analogy are types of inductive arguments. This means we do not speak of them as valid or invalid. They cannot be truth-preserving. So let me repeat that. Even if we can show that they have true premises, it doesn't guarantee a true conclusion. They are not truth-preserving. Instead, we speak of them as strong or weak. A strong argument is one that is most likely to lead to the conclusion. A weak argument is one that does not have a strong connection to the conclusion. One where the basis that we are giving is not sufficient for what we want to say. Now, this can be confusing. A weak argument does not mean the conclusion is false. It just means the argument does not support that conclusion. Conversely, a strong argument does not mean the conclusion is true. It just means that it would support the conclusion's truth. So again, weak does not mean false conclusion. Strong does not mean true conclusion. These are questions about the structure of our argument, not the truth of its conclusion. So let's review. In a previous flip, I showed you this. Now, deductive arguments and statements. Statements are true or false. Deductive arguments are valid or invalid. Now, valid or invalid looks at whether or not we follow rules that are truth-preserving. So if it is a carrot, then I don't like it. It is a carrot, therefore I don't like it. So this argument is truth-preserving. This is the form modus ponens, which is a valid form. Conversely, statements are true or false. So true or false looks at whether a statement describes what happens in the world. So it is minus 8 degrees centigrade right now. This statement is not true today. It is false. Now if it were true, then it would contribute in this way. If an argument is valid, it contributes in this way. Now, if we have something where there's true premises and a valid form, this will guarantee us a true conclusion. This, in turn, is called soundness, and this is an important thing for deductive arguments. Now I want to show you a different chart. I want to compare statements and inductive arguments. Now, inductive arguments, like deductive arguments, are not true or false. Statements are, again, true or false. So, true or false looks at whether what a statement describes happens in the world. Again, it is 8 degrees centigrade outside right now, minus 8 degrees centigrade outside right now. If this is actually the case, we have a true premise. If it is not the case, we have a false premise. Inductive arguments are strong or weak. Strong or weak says how likely it is the conclusion would be true based on an inference. 推測, 推理. Now, the last 10 times I ate cauliflower, I didn't like it. This would help me to believe I don't like cauliflower. This would make something probable. If this is true, and what I'm saying is probable, this means nothing. This does not guarantee a true conclusion. It encourages the conclusion's probability, but unlike a truth-preserving argument, it doesn't guarantee it. So I can have all true premises and a strong form, and it still is not going to guarantee me a true conclusion. Now, it probably would be true. But notice the use of the word probably. This is because I cannot guarantee the truth of it. So let's compare them again now that we've looked at them some more. So for a deductive argument, good form is valid as opposed to invalid. For an inductive argument, good form is strong as opposed to weak. If it has good form plus true premises, a deductive argument, the conclusion must be true. Again, this is the term soundness. If it is inductive, if it has a good form, meaning it's strong, plus it has true premises, the conclusion might still be false, because this is the way that inductive arguments work. Limitations. Deductive arguments, every statement must be true or false. We can't have anything that's most likely the case. We can't really have decimals, basically. It's 1 or 0. We're limited to a small number of operators, and it works in a very precise way. It's hard to make these sorts of arguments. It's hard to make the proofs sometimes, but if you do it, you can show if something's valid or invalid. Now, inductive arguments can accept partial statements. They can also have an unlimited number of ways they go. So we looked at two different types. We looked at arguments by analogy, and we looked at generalizations. Both of these are types of inductive arguments. Now, a deductive argument never guesses. By that I mean it's always sure. An inductive argument always guesses. It's never completely sure of what it's saying. It's always working towards something. Now, in Japanese, the one is an en-ekiteki ronsho. The other one is a kinoteki ronsho. So if that helps you to find further resources, good luck. If you have questions, always feel free to ask me. So now I want to summarize briefly what we looked at in this course. In this course, we looked at what you do when you encounter arguments. And I have told you many times, and I'm going to repeat it here. The first thing you should do is you should find the premises and the conclusion. Another idea, concept of a statement. A statement is a sentence or claim that is true or false. We also looked at the basic rules for making good arguments. So I summarized these under the heading, be clear. That means be concise. So say it in as few words as possible. Be concrete. So make your argument as clear as you can in terms of understandability. Use things that are real. Be consistent. Use words in the same way the entire time that you're making your argument. Finally, we also looked at deductive arguments. I gave you 5 forms. Modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, and dilemma. So if you want to look at those, they're on a previous flip. We looked at 4 operators. Negation, meaning not. Conjunction, meaning and. So many Japanese readers will look up conjunction and find the word setsuzokshi. But that's not the right meaning of conjunction for critical thinking. In critical thinking, conjunction means and. Disjunction. Disjunction means or in critical thinking. And finally, a conditional, which is an if-then sentence. We also looked at the concept of validity. The concept of validity is that if you follow the rules for making a deductive argument, then if your premises are true, your conclusion must be true. The name of this idea is truth-preserving, the idea that you could have true premises that will guarantee you a true conclusion. Finally, if you have a valid argument and you have true premises, you reach soundness, which is a valid deductive argument with all true premises and therefore a true conclusion. We looked at arguments by analogy, where I suggested the main problem is fit. And by fit, I mean that it should have the most in common in the most relevant ways. So for instance, if we wanted to make an argument about the nature of a tripod and the nature of me, if we make the argument that I'm a human being, I'm 183 centimeters tall, I live in Japan, and then we said the tripod is 183 centimeters tall, the tripod lives in Japan, therefore the tripod is a human being, this would be weak, because the fit is not strong in relevant senses. So it's not merely quantity, it's also the type of fit, and it's best if it fits very closely with what we're trying to argue. Finally, we looked at generalizations, where I suggested a few rules that can help you here. Quantity of examples. So the more data you can add, the better. Quality of examples. So again, we want to look at the right sort of data. So if I collect hundreds of data points, but they have no connection to what I'm talking about, this doesn't help. As an example, if I want to study what children think, it seems like it's a really bad idea to just ask adults, what do you think? And then use this data to talk about children. This makes no sense. If I want to know what children think, I should ask children. So this is quality of examples. So also I should look at the best data that I can find. Background rates. If I'm going to draw a conclusion, I should think, does that make any sense against the background? So if I said, everyone in this restaurant speaks Japanese, but it happens to be the case that I'm in the middle of America and there's no reason for me to think that, there's a problem. Now, it's never impossible for this to be correct even with the background being off, but we should always check with our background. The other thing that we looked at today is overgeneralization. So be careful about the word choices we use when we make generalizations and the scope of the generalizations we make. So try not to make generalizations that are bigger than what we can say. So I do hope that you've enjoyed this class. I don't know if it's been useful to you. If you have questions or comments, please feel free to leave them on the YouTube video. Best of luck.